Hi everyone, and welcome to The Sleepy Scientist. I'm really happy you're here. Tonight, we're going to go on a calm and quiet trip to learn something amazing. So get comfy, take a deep breath, and let's enjoy this peaceful science story together. Before we start, tell me in the comments, where are you watching from and what time is it for you right now? If you like relaxing science videos, don't forget to tap the like button. Now let's begin. Far away, in corners of the universe where the sky has never known silence, there are stars that dance in a way that seems impossible. They do not drift slowly like the gentle shimmer of most starlight. They spin wildly and endlessly, like tops wound too tightly by some cosmic child. These stars are called pulsars, dead stars, collapsed stars, remnants of once mighty suns, and yet they move with a fierce kind of life. A pulsar is born in an instant of destruction. When a giant star dies, it does not quietly fade away. It collapses under its own weight, its core crushed by gravity so completely that protons and electrons are pressed into neutrons, and the whole heart of the star shrinks to the size of a city. What remains is a neutron star, unimaginably dense and strong. And some of these neutron stars spin. Some spin once every second, others spin hundreds of times in that same second, faster than any human machine, faster than the blink of thought. Imagine standing on such a star. Of course you could not. The gravity would pull you down with a force 1 billion times stronger than Earth's. A spoonful of its matter would weigh as much as a mountain. And yet in this crushing place there is motion. Endless, whirling clockwork motion. These pulsars emit beams of light and radiation from their magnetic poles. As they spin, these beams sweep through the cosmos like lighthouse signals. When those beams point toward Earth, we see them flash, flash, flash like a heartbeat in space. It is not a light we see with our eyes, but a pulse we detect with careful instruments and sensitive radio telescopes. For a long time, these signals puzzled astronomers. When the first pulsar was discovered in 2007, then it pulsed so perfectly, so regularly, that scientists wondered if it might be artificial. They even nicknamed it LGM1 for Little Green Men. But it was not a message, it was a rhythm, a song of sorts, sung by a spinning corpse of a star. Now imagine the silence of the night sky. To our eyes, stars twinkle gently, but out beyond what we can see, the universe is filled with these ticking hearts. Over 3,000 pulsars have been found in our galaxy alone, though there are surely many more, hidden or turned away from us. Some are lonely, others are in pairs, orbiting other stars, tugging and pulling in gravitational dances that last billions of years. There is one called PSR J154822446. It spins 17 times every second. Nothing else known in nature spins that fast while holding together. It is spinning so quickly that if it were only slightly larger, it would fly apart. But it doesn't. It balances on the edge of physical law, teetering between order and collapse, yet remaining steady, like a spinning coin that never falls. These stars were not always this way. Once they were brilliant, burning giants, casting warmth and light. But death in the cosmos is not a true ending. It is a transformation, and in this case a star's final breath becomes a kind of whispering wheel, a memory that turns forever. Some pulsars slow down over time. Others, in binary systems, gain material from companion stars, spinning faster and faster as if fed by the touch of another. These are called millisecond pulsars, and when their companions fade or die, the pulsars remember them not with sorrow but with motion, keeping their shared rhythm long after the partner is gone. Close your eyes and think of that. A dead star spinning in silence, reaching across space with invisible arms of radiation, pulsing in perfect time for millions or billions of years. It is easy to forget that the universe is alive with this kind of beauty. Quiet, mathematical, and deeply poetic. A machine built by collapse, powered by memory, radiating into the infinite dark. We cannot feel these pulses with our skin, we cannot see them with our naked eyes, but they are there, and every time we listen the universe becomes just a little less still. Let's drift closer to one. Imagine orbiting it quietly from a safe distance. You would see the beams flick out into the black like twin searchlights. You would hear nothing, feel nothing, except the ticking of time itself. In a way, pulsars are clocks, the most reliable clocks in nature. Some are more precise than the atomic clocks we build on Earth. Scientists use them to measure the passing of time across space. We can track gravitational waves, detect planetary systems, and map the curves of space-time itself using these ancient stellar beacons. These strange spinning stars have become tools, guides, even companions. They whisper in rhythms we can learn from, but they are more than machines. They are stories. Each one holds the history of a star that lived, burned, collapsed, and found a new kind of existence. And in their endless turning there is a kind of grace. They remind us that even after destruction something beautiful can remain, something ordered, something that pulses in the dark, steady and true. So when you look up at the sky tonight, know that somewhere far away, a star is spinning not in chaos, but in calm. Its light may never reach us, its sound may never touch our ears, but its motion continues. It has become a rhythm in the great silence. It has become the kind of strange that feels almost like music. Now, let's drift deeper into the spinning quiet of these stars and feel what they truly are. Not just as physics, but as echoes of time, as stitched threads in the fabric of the universe. A pulsar is not merely a fast-spinning object in space. It is a memory with mass, a rotation carved by collapse, and a lesson in how the cosmos keeps its stories. The core of a massive star collapses into a neutron star with such density that atoms themselves are pressed beyond their natural forms. Inside there is no room for space between particles. The matter is compressed into a state so strange that it defies normal experience. This is a world where a single cubic centimetre weighs more than Mount Everest. The very idea of solid changes. And from this impossible compression comes that spinning pulse, as if the star is remembering what it once was through motion. The magnetic fields of a neutron star are millions to trillions of times stronger than anything we can create. These fields, locked into the star's structure, create funnels that guide radiation outward in narrow beams. Every turn of the star sweeps these beams across the sky like the hands of a celestial clock. But clocks do not usually sing, these stars do. There is one pulsar called the Crab Pulsar, the heart of a supernova that Chinese astronomers recorded in the year 1054. It still spins, still pulses, its energy casting a swirling cloud of light around it. The Crab Nebula. That pulsar is like a heartbeat that has never stopped, thumping 30 times a second, ever since the night that star died in brilliant fire. Scientists study this pulsar not just because of its beauty, but because it is reliable, a constant in a universe of change. And yet even these constants can jump. Pulsars sometimes experience glitches, sudden changes in their rotation rate. These glitches are like cosmic hiccups, revealing the fluid-like interior of the star, where strange forms of matter shift and realign. These momentary slips tell us that even something as steady as a pulsar holds deeper mysteries, layered and unfinished. Now think about time. On Earth, time is measured by the ticking of clocks, by the rising and setting of the sun, by the beat of a heart. But pulsars give us a new kind of time, a time written in space itself. Their pulses are so regular that we can use them to navigate like celestial GPS. Some scientists dream of building a cosmic timekeeping system based entirely on pulsars, allowing spacecraft to find their way through deep space, using nothing but the signals of these stars. It's not just a dream. NASA has already tested this idea using an instrument called Sextant aboard the International Space Station, which successfully used pulsar timing to locate itself in orbit. Proof that these strange spinning stars can become the wayfarer's compass in the vastness of space. There's something beautiful about that. A dead star, invisible to the naked eye, becomes a whispering lighthouse guiding us through the dark. And it doesn't stop there. Pulsars have become laboratories for the most extreme physics. Because their gravity is so strong and their motion so precise, they allow scientists to test the limits of Einstein's theory of general relativity. Some pulsars orbit black holes or other neutron stars, and their paths trace the subtle curves of space-time itself. In 2020, scientists observed a system called PSR J0737-3039a-B, a pair of neutron stars spinning around each other in a tight dance. One of them acts as a pulsar, flashing its beams, while both orbit in a way that bends and twists according to relativity. Watching them is like watching gravity write with invisible ink. Each shift in the pulse tells a story about the nature of space and time, mass and motion. Some pulsars even have planets. In 1992, astronomers discovered the first exoplanets not around a sun-like star, but around a pulsar. These were the first worlds ever confirmed beyond our solar system, orbiting a star that had already died. The planets are bathed not in sunlight, but in harsh radiation, and they are likely uninhabitable. But still, they exist, and their presence reminds us that life, or the memory of life, or at least the conditions for orbit, can exist even in the aftermath of catastrophe. What a strange and hopeful thing. Planets circling a collapsed sun, dancing in the glow of a star that remembers through spinning. Pulsars also help us listen to something even deeper, the low, rumbling waves of gravity itself. Gravitational waves are ripples in space-time caused by massive objects moving and colliding like black holes merging. These waves are hard to detect, faint and so, but pulsars with their perfect timing can act like sensors. By measuring the timing of many pulsars scattered across the sky, a project called a pulsar timing array, scientists can detect these waves as they subtly stretch and squeeze the space between Earth and the stars. And in 2023, such a signal was finally found. It wasn't a sudden chirp, but a background hum like the deep breathing of the universe heard only because these stars kept whispering their pulses across space for years. Now close your eyes and let that sink in. There is a hum out there, a low murmur that has always been there, and we have only now begun to hear it. And we hear it not with ears, but with the help of spinning stars, the remnants of ancient deaths. These pulsars, these strange and steady things, are helping us hear the very shape of the cosmos. They are like musicians who never stop playing, letting us know that space is not silent, not truly. That time itself can have a rhythm. That memory can take the shape of motion. So when we talk about pulsars, we're not just talking about astrophysics. We are talking about time and loss and rhythm and pattern. We are talking about the way the universe remembers itself, not with photographs, but with spinning wheels of light. They teach us that even in death there can be structure, even in collapse there can be grace, even in silence there can be music, and somewhere out there, always, there is a star spinning fast, holding itself together against all odds, pulsing its heartbeat into the dark, saying, "I was here, I still am." Now let us settle into the final stretch of this spinning tale, not with urgency, but with the gentle patience of the universe itself, as if we're riding alongside one of these silent stars, feeling its steady rhythm in the marrow of time. Imagine floating in the vacuum, a slow drift through blackness unbroken by sound, yet not empty. Ahead, a pinpoint of light pulses in perfect rhythm, too distant to blind you, too consistent to ignore. That light is not just a beacon, it is the breath of a star long since collapsed, a ghost of fire now bound by gravity's tightest grip, spinning like a memory that refuses to fade. It does not burn, not in the way our sun does. It radiates from magnetic seams, from rotation, from the alignment of ancient forces. And in its spinning, it speaks a kind of lullaby to the void. You begin to realize that this universe, vast and cold and uncaring as it might sometimes seem, still holds rhythms, still holds secrets that are not shouted but softly repeated again and again over eons. Among the most haunting discoveries in this realm are the so-called Magnetars, a rare and extreme form of neutron star where magnetic fields are not merely strong, but almost unbearable in scale. A magnetar's field can be 1,000 times more intense than that of a typical pulsar, powerful enough to twist atoms, to fracture its own surface in a quake of stellar skin, releasing flares brighter than 1,000,000 suns. When a magnetar hiccups, whole galaxies notice. One such event in 2004 from a magnetar known as SGR 180620 sent a wave of gamma rays that briefly ionized Earth's upper atmosphere, even though it was 50,000 light-years away. And yet, despite this violence, the Magnetar 2 is bound by rhythm. It spins, it pulses, it continues, and its light still takes its turn among the stars. In another part of the sky, astronomers found pulsars that vanish. These are called rotating radio transients, or RATs. Their pulses flicker and fade unpredictably, like cosmic candlelight in a wind we cannot feel. For minutes or hours they go dark and then they return. No one knows exactly why. It could be a shift in the magnetic alignment or a complex dance of plasma around the star's poles. But perhaps it is something simpler. Perhaps even stars have moments when they pause, when their voice grows quiet, when their message fades into the static of space, only to return again, softer, but still there. These quiet intervals give them a strange kind of vulnerability. They are no longer the perfect clocks, they are wanderers, uncertain, and maybe that makes them more like us. As we zoom out farther and farther, letting these stars shrink back into their dots of brilliance, we begin to see something else. Pulsars arranged not just in isolation, but in patterns, across space. They are being catalogued not only as phenomena, but as tools for building something more, a map of the invisible. Pulsar navigation is not a fantasy. With enough of them carefully tracked, a spacecraft could one day travel the galaxy the way ancient sailors used constellations. Pulsars, unlike planets or moons, don't drift from their rhythm. Their very predictability makes them ideal cosmic lighthouses. Already the Voyager spacecraft, launched decades ago, and now in interstellar space, carry golden records engraved with the positions of 14 pulsars, each with a distinct pulse rate, so that any finder in the cosmos might locate Earth using these strange stars. That's how closely tied our story is to theirs. We've written our location in their rhythm, hoping that someone else, somewhere, someday, will hear the beat and understand. But maybe the most poetic truth is this: pulsars exist because something ended. A star died, its core collapsed. And yet out of that ending came a new kind of order, something that did not rage but turned quietly in the dark, holding its shape with dignity. Pulsars are proof that the universe does not always erase what it destroys. Sometimes it transforms, sometimes it gives the fallen a new role, not as light givers but as timekeepers, guides, witnesses. They do not ask to be seen, they do not shine in glory, but they endure, and in that endurance there is grace. Even now, new pulsars are being discovered. The universe reveals them one by one, like seeds buried in the dark that suddenly sprout not with green, but with light. Each discovery adds another voice to the silent chorus of spinning stars. Some are slow and heavy, turning once every few seconds. Others are impossibly fast, whirling hundreds of times a second, as if trying to outpace the collapse that birthed them. They are not new stars, but the echoes of old ones. They are the music that lingers after the concert ends. And what does it mean, really, that we can listen to them? That we, tiny creatures on a blue planet spinning ourselves, can build machines to catch their pulses, to time their spin, to trace their gravity. It means that we are not separate from them. We are part of this rhythm. Our atoms, forged in stars like them, our bones echoing their collapse, our curiosity lit by their distant fires. We are not merely observers. We are made of the same silence, the same pressure, the same stardust that now sings through the spin of a neutron core. So the next time you lie beneath the night sky and see nothing moving, nothing pulsing, nothing strange, remember the ones you cannot see, the ones whose light is not visible, whose sound is not heard but who continue all the same. They are the keepers of cosmic memory, the survivors of stellar death, the musicians of deep time. They are strange, yes, but strange does not mean chaotic. Strange can be structured, strange can be beautiful, strange can be steady. And that is what the pulsars teach us, that in the quiet turning of broken things there is meaning, that in the heart of collapse there can be rhythm, that even at the edge of what we understand something waits, not to dazzle us but to continue, to spin, to pulse, to whisper across space. I was once fire, I became gravity, now I am time, and I am still here. Somewhere beyond the soft blue curve of our sky, in places so distant that light forgets how long it's been travelling, there are regions where the universe folds in on itself, where space and time surrender to gravity, and silence becomes so deep it hums. These are black holes, not holes in the way a tunnel is hollow, but dense collapsed hearts of stars, curled so tightly by gravity that nothing, not even light, can escape. And yet, despite their silence, they are not empty. They are not absence, they are presence made perfect. A black hole begins its life not with a shadow but with fire. A massive star many times larger than our sun burns through its fuel and swells with heat and light. Then suddenly it can no longer hold itself up. Gravity wins, the core collapses inward, falling into itself, becoming denser, heavier, smaller, until the collapse becomes infinite, or so close to infinite that no known force can stop it. What's left behind is invisible, but not undetectable. The star's surface may be gone, but its mass remains, concentrated into a point with no volume. Around this point is a boundary called the event horizon, the place beyond which nothing returns. Cross that line and escape becomes impossible. But before that line, light bends. Time stretches. Reality begins to warp. Imagine drifting near one. You wouldn't fall in suddenly. You would orbit. You would feel time stretch around you like taffy, slower the closer you drift. If you looked back toward Earth, clocks would tick faster. If someone watched you from far away, they would see you slow, as if sinking into a frozen moment. The black hole's pull is immense, but so is its silence. It does not scream, it does not burn, it waits, and yet the space around it is not quiet. It glows, not from the hole itself, but from the matter that dares come near. As dust, gas, or even stars spiral toward the event horizon, they accelerate, heat up and radiate light. These glowing disks of matter are called accretion disks, and they can shine brighter than entire galaxies. It is strange to think of the brightest light in the sky coming from something that swallows all light, but this is how the universe often speaks, in paradoxes, in echoes, in opposites that hold hands. Some black holes are small, no larger than a city, remnants of single stars. Others sit at the hearts of galaxies, called supermassive black holes, with masses millions or billions of times that of our Sun. These giants do not orbit, they anchor. The stars, dust and gas of entire galaxies whirl around them, bound in dance to their gravity. Our own Milky Way has one, Sagittarius A, a quiet, invisible centre, nearly 4 million solar masses tucked into a space no larger than our solar system. It does not blaze, it barely feeds, but it is there, holding the shape of our galaxy like a still hand beneath a spinning plate. And then there are collisions. Sometimes two black holes find each other. They circle, slowly at first, then faster, then impossibly fast until they spiral inward and merge. When they do, they send ripples through the very fabric of space, gravitational waves. These waves stretch and squeeze space-time itself, and they move outward at the speed of light, soft as whispers, strong as earthquakes. We detected them for the first time in 2015 using the Laser Interferometer Gravitational Wave Observatory, or LIGO. Two black holes, 1 billion light-years away, merged, and their silent song reached Earth as a tremble in space-time, barely wider than a proton, but real. It was the first time we had heard black holes speak, not with light, but with motion, not with sound, but with the bending of reality. They sing in silence, yes, but we are learning to listen. Each merger brings more waves, each wave carries a story, the mass of the black holes, their spin, their distance. It is as if we are tuning into a radio station where the notes are made of gravity and the instruments are stars collapsing. These are not songs for our ears, but for our instruments, for our models, for our dreams, and they do not fade. The universe holds on to the memory of each collision, sending it outward forever. Now picture something even stranger, a black hole with a companion orbiting like a binary star. As the black hole pulls matter from its partner, that matter forms a disk and shines with X-rays. These systems are called X-ray binaries, and they flicker in rhythms that can be measured. Their pulses are not smooth. They are chaotic, noisy, but regular enough to be recognized. Scientists have found patterns in these emissions, quasi-periodic oscillations, echoes in the light. Some think these may be signs of matter spinning just outside the event horizon, trapped in a loop, circling endlessly before vanishing. These flickers, these pulses, might be the last breath of things before they disappear forever, but the black hole is not the end. It is a question, a door, a place where our laws of physics begin to fail. At its center lies a singularity, a point of infinite density, where space and time collapse together. We do not know what exists there. Our equations break down. Our understanding thins like the edge of a dream. Some believe that all information falling into a black hole is lost. Others argue it is preserved, somehow encoded on the event horizon, like data on the surface of a hologram. This debate is not small. It touches the heart of what science is, the promise that we can understand the world through patterns, through cause and effect. If information can be destroyed, that promise breaks, but if it is preserved, even in a strange and unreadable way, then perhaps nothing is ever truly gone. This is what makes black holes so haunting. They are not only physical objects, they are puzzles. They challenge our sense of order, of visibility, of permanence, and yet they exist. They shape galaxies. They carve the paths of stars. They create the loudest silences in the cosmos. And they are not rare. The universe may be filled with them. Every large galaxy likely has a supermassive black hole at its heart. Stellar black holes are born in supernovae all the time. Some roam alone, dark and unseen, waiting in the void. Others feed and flare and vanish again. And still we look, we listen. We build instruments more sensitive than ever, hoping to catch more trembles, more whispers, more of the black hole's silent songs. Because even in their darkness they illuminate something within us, a hunger to know what lies beyond, quiet longing to hear what cannot be heard. The black holes that sing in silence do not shout their truths. They let us come closer inch by inch through gravity and time, through ripples and lightless spin. And when we arrive, what we find is not an answer, but a question that hums across the deep. What remains when everything else is taken away? Let's drift deeper now, into the quiet orbit of these shadow giants, where light coils and time folds like soft paper, where black holes do not just sit in space but reshape the story of what space is. Around a black hole, nothing behaves the way we expect. Time dilates, meaning that to an outside observer, anything falling into a black hole slows down, appearing to freeze at the edge of the event horizon. The falling object sees time continue normally, but for the watcher, it never quite crosses over. It hovers, faint, fading, stretched out into a ghost of itself. This isn't science fiction, it's how gravity bends time itself. Black holes are not just regions of space, they are distortions in the fabric of reality. They do not simply swallow, they sculpt, twisting the rules that govern how we move, how we age, how we understand cause and effect. Around them, light orbits in rings caught in endless loops. These are called photon spheres, places where light can circle a black hole without falling in, like fireflies trapped in an invisible jar. To see one would be to look into a mirror of infinity. But you cannot stand near a black hole. You would be stretched into what scientists poetically call spaghettification, where tidal forces grow so extreme that your feet would be pulled much harder than your head, elongating your body into a thin stream of atoms. It is a painful image, yet elegant in its strangeness. Even destruction near a black hole becomes an expression of gravity's art. And while this fate sounds final, the reality is more curious. Black holes evaporate. Very slowly, over eons, they lose mass through a process called Hawking radiation, named after physicist Stephen Hawking, who proposed that black holes are not entirely black after all. At their edges, particle pairs form from the quantum vacuum. One falls in, the other escapes. The escaping particle carries energy, and thus, over unimaginable time, the black hole shrinks. A supermassive black hole would take longer than the current age of the universe to evaporate, but the principle remains. Even the most permanent things we know are not truly eternal. They dissolve, they fade, even silence has an end. Consider now the sound of silence itself. In 22, astronomers translated waves from a black hole at the centre of the Perseus cluster into audible frequencies. The actual pitch of the waves was millions of times lower than human hearing. But once scaled, they revealed a deep, eerie hum. It was the closest we've come to hearing a black hole's voice. It was not a melody, it was not chaos, it was tone, steady and low, echoing through the hot gas of intergalactic space. This sound came not from the black hole's core, but from pressure waves. Ripples sent out by the black hole as it interacted with its surroundings. It's strange to think of a hole singing, but in this way, black holes do not just pull in. They push out, they influence, they stir the space around them like a spoon in honey, sending waves across millions of light years. These waves do more than make sound. They heat the gas around them, prevent star formation, regulate the growth of galaxies. A black hole at the centre of a galaxy can shape that galaxy's fate. If it feeds too quickly, it blasts jets of energy that sweep away the gas needed to form new stars. If it starves, the galaxy may grow cold, empty of the material for future suns. This balance, this push and pull, is a kind of cosmic feedback. A conversation between gravity and light, between silence and motion. The black hole speaks not in words, but in influence. It shapes the lives of stars without ever touching them. We used to think of black holes as destroyers, but now we know they can be creators too. Their mergers create gravitational waves. Their disks create light. Their spin creates jets, streams of particles launched at nearly the speed of light, extending for hundreds of thousands of light years. These jets are narrow and bright, carved by the magnetic fields wound tight around the spinning black hole. They emerge not from within the black hole, but from the chaos just outside it, where matter churns in plasma spirals. Some galaxies have twin jets that glow in radio waves, painting the sky with invisible lines of force. These lines map the influence of a black hole across space, its arms extended not to pull but to point. One of the most beautiful discoveries in modern astronomy came in 2010, when scientists using the Event Horizon Telescope captured the first image of a black hole's shadow. It was not a photograph in the ordinary sense. It was the result of a global collaboration, linking telescopes around the world to create a planet-sized eye. What they saw was not the black hole itself, but the silhouette of its event horizon, surrounded by the glowing halo of its accretion disk. A dark center, fringed in fire, floating in the void. This image was more than a scientific achievement. It was a message. We can see the invisible. We can glimpse the shape of the impossible. We can bring light to the edge of nothing. And what lies beyond that edge, we don't know. Some theories suggest black holes could be portals, bridges to other universes, wormholes folded in space. Others imagine that what falls in might not be lost, but reborn elsewhere, in some mirrored reality or distant future. There is no evidence for this, only equations that permit it. But the idea itself is telling. We are drawn not just to black holes as mystery, but to the possibility that they are not dead ends, but beginnings, that beyond their darkness is something more. Now float a little farther out. Picture a galaxy, its spiral arms spread like petals, its stars moving in harmony. At its center lies a supermassive black hole, quiet and unseen, yet holding the galaxy together with its gravity. Without it, the galaxy might unravel. With it, the stars move in ordered grace. This is not tyranny. This is structure. The black hole is not a ruler. It is a root. It anchors the galaxy's bloom, allowing light to flourish around its darkness. There is comfort in that image, that even in the heart of silence there can be harmony, that something as strange as unknowable as a black hole can still give shape to beauty. We do not need to fear them. We only need to listen, to observe, to wonder. They are reminders that the universe holds secrets not meant to harm us, but to humble us. They show us the limits of our sight and the strength of our curiosity, and they invite us to come closer, not recklessly but reverently, to learn not by conquering but by contemplating. Because in the end, black holes do not speak in explosions, they speak in curves, in time stretched thin, in orbits that shimmer just outside the edge. They speak in waves that move through spacetime like ripples in a pond too large to cross. And if we are quiet enough, if we build the right instruments and ask the right questions, we can hear them, not as noise but as the deepest, most ancient form of order. A silence that sings, a darkness that reveals, a mystery that waits. Let us now enter the final orbit of this mystery, circling slowly without haste around the deepest questions that black holes raise, not just in space but in us, for these cosmic shadows are more than objects of study. They are mirrors held up to the edge of understanding, inviting us to peer into the unknown. And when we do, we find something more than fear, we find wonder. For all their silence, black holes stir something ancient in the human heart, a longing to understand what lies behind the veil, a quiet yearning to find meaning in what cannot be seen. And so we observe, we calculate, we imagine, but we also feel as if somewhere deep within, our own thoughts orbit mysteries just as vast. Think of information now, not the kind we write in books or store on drives, but the fundamental data of existence, the position of every atom, the shape of every field, the past trajectory of every photon. According to our best physical theories, information cannot be destroyed. And yet, when something crosses the event horizon of a black hole, that information seems to vanish. This is the information paradox, one of the most profound puzzles in all of physics. If information truly disappears into a black hole, then the laws of quantum mechanics must be wrong. If it is preserved, then somehow the black hole must store or radiate it in ways we cannot yet decode. In recent years, some have proposed that information is smeared across the event horizon in a thin layer of quantum fuzz, like ink on the surface of a bubble. Others believe it escapes slowly with Hawking radiation, encoded in subtle quantum patterns too complex to read. These are not just technical debates. They are the search for the soul of reality. Black holes force us to ask, is the universe logical? Is it reversible? Is memory ever truly lost? Some scientists believe the answer lies not in black holes alone, but in a broader theory that unites gravity and quantum mechanics, a theory of quantum gravity. We do not yet possess it. String theory, loop quantum gravity, holography. Each offers glimpses, but no final picture. Black holes are the testing ground. They are the thought experiments where our equations face the most extreme conditions, and still, they hold firm. They persist. They hang. Now return again to the idea of sound. Not the scaled down hum we can hear, but the deeper resonance. Gravitational waves, the silent ripples that pass through everything. Since their discovery, scientists have begun cataloguing them, turning each black hole merger into a line in a cosmic symphony. Some are light and quick, stellar mass black holes colliding like cymbals in the dark. Others are slow and massive, supermassive black holes whose spiral takes millions of years, sending out deep, slow beats that stretch across galactic distances. We have only begun to listen. Future telescopes like LISA, the Laser Interferometer Space Antenna, will float in space listening with greater sensitivity, catching lower and fainter tones. One day we may build an entire observatory of time and silence, mapping the unseen universe through vibration alone. And perhaps in this map we'll find something even stranger. Some speculate about primordial black holes, tiny ones formed in the first seconds after the Big Bang, when the universe was hot and dense and chaotic. If they exist, they could be no larger than mountains or even atoms, yet with the weight of worlds. These relics would be ancient, older than stars, wandering the universe unseen. Some theories even propose that dark matter, the invisible mass that holds galaxies together, might be made of such black holes. If true, it would mean that the very shape of the cosmos is defined by the silent paths of vanished stars. But even more astonishing is the possibility that black holes are not ends, but beginnings. There are theories, speculative but beautiful, suggesting that the interior of a black hole might give birth to a new universe. In this view, every black hole is a seed, and inside it lies not destruction but creation, a bounce, a bloom, a new beginning unfolding behind the veil. We cannot test this yet, we may never be able to, but the idea itself is a kind of poetry, that even in the deepest collapse something new may emerge, that endings may be entrances, not exits, that what we call nothing may simply be the silence before the next beginning. And so we return to the metaphor we've circled all along, the song. Black holes do not have mouths, they do not speak, but through gravity, through radiation, through ripple and rhythm, they create patterns that can be translated into meaning. They become instruments of insight, carving the shape of space, guiding the motion of stars, revealing the hidden harmonies of the universe. Their songs are not loud, but they last. They echo across time. And now we are beginning to hear them. Perhaps that's what matters most. Not that we solve every equation or pierce every horizon, but that we learn to listen, to the silence, to the mystery, to the quiet truths hidden in the dark. Black holes, once thought to be the erasers of the cosmos, have become its teachers. They remind us that darkness does not mean absence, that silence does not mean stillness, that even in collapse there is structure, and even in the unknown there is beauty. So when you next look up at the stars, know that somewhere in that sky, invisible but vast, a black hole is spinning. Maybe it's pulling in gas from a companion star, lighting up in X-rays. Maybe it's colliding with a twin, sending out waves that will one day pass through you, stretching your atoms ever so slightly. Maybe it's alone, quiet, dark, fading through Hawking radiation as the universe grows cold. Whatever its fate, it endures. And its endurance shapes the very fabric of the cosmos you live in. And perhaps quietly, gently, it shapes something in you as well. A sense of awe, a sense of peace, a sense that even the darkest places can hum with unseen life. Black holes may never be fully known, but they will always be present, not as monsters but as melodies, not as voids but as voices, not as ends but as beginnings that refuse to shout, choosing instead to sing. Out in the quietest regions of the universe, beyond the clusters and spirals, beyond the elegant wheels of starlight we call galaxies, there are loners, vast collections of stars adrift, moving through the dark with no neighbours, no orbit, no anchoring cluster to belong to. These are the rogue galaxies, the wanderers, the galaxies that have no home. They drift like cosmic icebergs, silent and massive, far from the gravitational embrace of any larger structure. Their paths are lonely, their light dim, yet their stories are among the most mysterious the universe has to offer. For in a cosmos that is always pulling things together, stars into galaxies, galaxies into clusters, clusters into webs, how is it that some are left behind, or worse, pushed out? To understand these galactic exiles, we must first understand what it means to belong. Galaxies are rarely alone. Most live in groups, clusters or superclusters, cosmic cities held together by gravity, woven into the filamentous structure of the universe. Our own Milky Way lives in a small group with Andromeda and a few dozen smaller galaxies, and together we orbit within a larger region called the Laniakea supercluster, one stream in a web of cosmic structure. In these neighbourhoods, galaxies interact constantly. They pass close to one another, their edges brushing like dancers in a slow waltz. Sometimes they collide, merge, or tear each other apart, sending long ribbons of stars trailing into space. Gravity holds them close, but it also plays rough, and every so often a galaxy is flung away, exiled by the very dance that once embraced it. These are the rogue galaxies. Some were once part of tight clusters, until a near miss or multi-body interaction launched them out at incredible speeds. Others may have formed in isolation, in underdense regions of the universe where matter was too thin to clump tightly. However they came to be, they now drift through the intergalactic void, a darkness so complete that even light seems slower. The space between galaxies is not entirely empty, but it is vast and quiet. A lone galaxy here shines like a lantern in fog, its stars twinkling into the silence with no one to echo them back. There is something deeply human about this idea, about being cast out, about wandering without a frame of reference. These galaxies are not smaller, not necessarily weaker. Some are massive ellipticals, rich with stars. Others are younger, still forming, their gas clouds glowing faintly with newborn suns. But without a nearby galaxy to reflect or distort their light, they are harder to find. For decades, astronomers missed them, their glow too soft to rise above the noise. But with the advent of more sensitive telescopes tuned to infrared and radio waves, we've begun to find them, not many, but enough to know they exist. And with their discovery comes the realization that even in cosmic loneliness, there is structure. Some rogue galaxies still carry companions, small dwarf galaxies that orbit like loyal satellites, clinging to the gravity of their wandering host. Others trail long tails of gas or stripped stars, remnants of a past interaction that sent them on their current path. These features are not just beautiful, they are evidence. They tell a history of movement, of encounters, of separation. One such galaxy, called NGC 1600, sits alone in an unusually empty region of space. Yet at its centre lies a black hole 10 times more massive than the one in our Milky Way. Its size suggests that NGC 1600 once lived in a more crowded neighbourhood, feeding off interactions, growing fat from cosmic mergers, until it found itself alone, king of a kingdom with no subjects. This solitude is not always the end of the story. Some rogue galaxies are caught again, pulled into new clusters over billions of years. Others remain solitary, drifting farther into the dark. The universe does not promise balance. It offers motion, and motion leads to separation as often as it leads to union. Yet even in that separation, these galaxies burn. Their stars live and die, their black holes spin. Their gravity shapes the path of unseen matter. They are not forgotten, they are just far. The voids they occupy are not mistakes, they are part of the structure of the cosmos itself. A vast sponge-like web of matter and emptiness. Galaxies gather along the filaments and walls of this web, while immense bubbles of near-nothingness stretch in between. These are the cosmic voids, some hundreds of millions of light-years across, nearly devoid of galaxies or matter. Within them, rogue galaxies float, like seeds caught between the ribs of a great skeletal structure. Their isolation allows them to evolve differently. Without frequent collisions or gravitational harassment, they age more quietly, their shapes are smoother, their gas more pristine. They are untouched, not by luck, but by distance. And so, the galaxies with no home become the keepers of a different kind of history. Not the crowded, tumultuous story of galactic clusters, but the slow, deliberate narrative of solitary evolution. They are quieter, but not simpler. They speak in slower tones. They teach us what it means to persist without guidance, to burn without an audience, to move through the vastness without losing structure. In this way, they are both metaphor and fact. Examples of what happens when the universe whispers instead of shouts. Close your eyes and picture one now. A lonely spiral, its arms trailing into the dark, no nearby neighbour to pull or distort it. Stars revolve with perfect grace, unhurried, unworried. Around it stretches emptiness, not as a threat but as a frame. Its light takes longer to reach anyone. Its pulses are softer, but it still spins, it still lives, it still matters. This is the strange elegance of rogue galaxies. They are the orphans of gravity, the wanderers of the dark. But in their solitude, they show us something rare. The shape of resilience, the light of things that endure beyond belonging. They are not broken, they are just elsewhere. And in that elsewhere, they remind us that the universe does not need a centre to hold beauty or a cluster to hold truth. Sometimes what is farthest away is clearest. Sometimes what stands alone shines the most. Now let's drift deeper into the silent spaces where these solitary galaxies glide, not as accidents, but as ancient witnesses to the universe's vast and delicate construction. Imagine the quiet corridors between clusters, immense, cold expanses where galaxies do not interact, where gravitational echoes fade into stillness. In these voids, rogue galaxies carry their own weight, moving not in chaotic spirals of activity, but in steady, untethered paths. Each one is a self-contained universe, with billions of stars swirling around a common center, a black hole nestled in its core, pulsing invisibly with quiet authority. And though no nearby galaxies orbit or crash into them, the inner lives of these wanderers are anything but simple. Their stories are written in starlight and shaped by the gravity of long-forgotten collisions, by winds from dead stars, by the memory of motion itself. Some of these galaxies may have been pushed into the void by dramatic encounters. In dense clusters, when 3 or more galaxies interact at once, the gravitational tug-of-war can fling one of them outward at great speed. This process, called three-body ejection, acts like a slingshot. The unlucky galaxy caught in the wrong place at the wrong time is cast out of the cluster's embrace and sent into the deep. These events are rare but powerful, and the ejected galaxy can travel millions of light years before it slows. It doesn't burn out or collapse, it simply drifts, carrying with it the memory of the encounter that sent it away. Its stars continue to orbit, its gas continues to churn, and its silence becomes a kind of testimony to how violence in space can lead not to destruction, but to solitude. There are other ways to become a rogue. Sometimes galaxies form in isolation, born in underdense regions where there was never enough matter to form clusters. These galaxies are not refugees, they are natives of the quiet. Their stars are younger, their gas less disturbed. They evolve more slowly, like wildflowers on a mountaintop untouched by footsteps. Their beauty is different, less sculpted by interactions, more shaped by internal balance. Scientists call them void galaxies, and they are often small, blue and rich in gas, cosmic reservoirs of potential, still building stars while their cousins in the city clusters have long gone quiet. In these galaxies, star formation continues gently, a soft, ongoing whisper instead of the roar of galactic collisions. And then there are the dark ones. Galaxies that contain stars but few enough that their light barely reaches us. Or worse, galaxies that seem to contain very few stars at all but massive halos of dark matter. These are ghost galaxies, detectable only by their gravitational influence on nearby matter, or by the faintest trails of starlight. Some researchers believe these dark galaxies are more common in voids, where gas never condensed into stars, or where something prevented the normal process of ignition. They move unseen, untethered, like phantoms passing through the cosmic fog, and yet they exist. Their mass is real. Their place in the structure of the universe is undeniable. Not all stories are told in light. Scientists are now using surveys like the Sloan Digital Sky Survey and the Dark Energy Survey to map these galaxies with increasing precision. They find that void galaxies are not randomly scattered, but aligned with the faint filamentary threads that stretch across emptiness, the gossamer strands of the cosmic web. Even in emptiness there is pattern. Even in silence there is song. These galaxies, once thought to be wanderers without cause, are part of the same vast structure as everything else, just living at the edges between the louder pages of the universe's story. Their paths follow the subtle curves of dark matter, the gravitational scaffolding that shapes all cosmic architecture. They are not beyond the web, they are its hidden stitches, and in their quiet, these galaxies preserve ancient things. Without the disruption of mergers or tidal forces, their stars age in peace, their chemical compositions remain simpler, less polluted by supernova remnants from other galaxies. They serve as time capsules, snapshots of earlier cosmic epochs preserved by distance. Astronomers study them to understand what the universe was like before the great clustering began. In their isolation lies clarity. Like untouched snow, they hold the imprint of first light, the chemistry of untouched hydrogen, the rotation of stars unwarped by their neighbours. There's even evidence that some rogue galaxies might harbour planetary systems, orbiting stars that have never felt the tug of another galaxy's gravity. Imagine a world in such a galaxy, its night sky a near perfect darkness, with only the faint glimmer of distant stars. No nearby galaxies to scatter light across the heavens, just a canopy of ancient starlight and the silent pulse of its own galaxy's heart. On such a world, the stars would drift slowly, with no rival galaxy rising like Andromeda in their sky, and life, if it ever arose there, would grow without cosmic interruptions, undisturbed by the gravitational chaos that reshapes clusters every few billion years. It would be a life lived in long seasons, in slow time under a sky that barely moves. But even these worlds, if they exist, are not beyond reach. Our instruments grow stronger. The James Webb Space Telescope, peering deeper into the void, may one day capture their light. Already it has found evidence of ancient galaxies formed just a few 100 million years after the Big Bang, some in surprising places, where we once thought the universe too empty to harbour such complexity. And so the boundaries shift. The once invisible becomes visible. The outliers become part of the pattern. And still these rogue galaxies drift. They do not cry out. They do not seek company, but they remain. Their presence softens our assumptions about how the universe works. Not everything must belong to a cluster. Not every galaxy needs a neighbour. Not every motion must lead to union. Sometimes to be alone is to preserve a different truth. Sometimes solitude is a kind of strength. In this way, the galaxies that have no home become cosmic poems, not because they are strange, but because they remind us of the many ways to exist, to move without being drawn in, to burn without being seen, to matter even when surrounded by emptiness. Their light may be faint, their voices may be few, but their stories are etched into the shape of space itself. And if we listen, if we look, they will always be there, gliding, glowing, enduring. Now let us complete this gentle journey among the galaxies that wander without a home, not with sorrow, but with reverence for what it means to continue alone. These galaxies, moving through the quiet intergalactic dark, do not shine for an audience. They do not collide in fire or fuse in spectacular mergers. They persist, they rotate slowly. Their stars are born in the hush of gravity and die in the silence of great distances. If we could sit upon a ledge just outside one of them, letting the stars turn below us like soft fireflies in a jar, we might understand something about the nature of solitude. Not as absence, but as a state of uninterrupted motion, a long and deliberate unfolding. These galaxies do not lack meaning because they drift. They carry meaning in their drift, in the way their orbits hold steady without interference, in the way their structure survives where nothing else touches them. One such galaxy, known as MCG 0102015, floats about 260 million light-years from Earth. It exists in a region almost entirely empty of other galaxies, a near-perfect cosmic desert. Its closest neighbours are more than 100 million light-years away, and yet it shines. Its spiral arms curl gently outward. Its centre glows faintly with aged stars. It has gas, it has motion, it has time. It is not lonely, it is simply alone, and there is beauty in that. Observing it tells us not just what galaxies are, but what they can be when given the room to unfold without interruption. The structure of such galaxies often reveals a purity. Without the gravitational shearing that comes from crowded clusters, their disks remain symmetric. Their halos of dark matter are less distorted. Their star populations follow more predictable age gradients. This clarity allows astronomers to study the slow internal processes of galaxy evolution without the complicating factors of frequent collisions or environmental effects. In other words, these rogue galaxies become laboratories of galactic solitude, revealing what happens when a galaxy gets to live its life quietly, away from the cosmic noise. And this teaches us something unexpected. In the great web of the universe, it is not only the knots and intersections that matter. The spaces in between, the voids, the margins, the drifting points, carry stories just as essential. Rogue galaxies are not errors in the structure, they are part of it. They help balance the large-scale flows of mass and energy. Their presence in voids affects how light from distant objects bends and scatters. Their distribution informs our understanding of dark matter. Even their absence from certain places tells us about the dynamics of cosmic expansion. But perhaps most astonishing is how these galaxies challenge our understanding of what it means to belong. In a universe where gravity is the great gatherer, where galaxies cluster and merge, where stars form in groups and atoms bind into molecules, the idea of something persisting alone feels foreign, and yet it is real. Rogue galaxies are proof that not all creation follows the same pattern. Some are shaped by encounter, others by avoidance. Grow through collisions, others through quiet accretion of gas and time. Some burn brightly at the centre of chaos, others flicker softly at the edge of silence. Even in that silence, though, there are echoes. The light from rogue galaxies travels across unimaginable distances, eventually reaching us, carrying the news of their endurance. When we detect that light, we are not just observing photons, we're receiving a message. That something survived in the dark, that something grew in quiet, that something held its shape despite isolation. It is a message of structure in absence, of resilience in stillness. And in these galaxies there is memory. Though they travel far from where they may have begun, though they are cut off from clusters and the gravitational exchanges that shape their cousins, they still bear within them the fingerprints of their origins, their chemical makeup, their rotation curves, the distribution of their stars, all hold clues to a past that once included connection. And so even in isolation, they are not truly disconnected. They are the carriers of ancient light, the wanderers who remember. The story of these galaxies also intersects with our own. Our Milky Way, while not a rogue, has known solitude in the past and may know it again in the future. Galaxies move, clusters evolve, and even the great cosmic web shifts over time. One day, far in the future, after the local group has merged, and as the universe continues to expand, we may find ourselves increasingly alone in space. The light from distant galaxies stretched beyond detection. In that far epoch, perhaps only local, merged remnants will remain, silent glowing embers in an otherwise empty sky. And in that time, whoever still looks upward may see what rogue galaxies see now, a vastness so wide it feels like stillness, a sky so quiet it becomes a kind of peace. But that is not a sad ending. It is a slow one, a gentle one, a natural one. The universe does not rush, it flows. And in that flow, the galaxies that have no home remind us that being adrift is not the same as being lost, that to journey without companions does not make one empty, that to glow alone is still to glow. Their light is not diminished by the distance it travels. In fact, its long voyage makes it more remarkable. Like messages sent in bottles across an endless ocean, the light from these galaxies reaches us across billions of years and speaks not of tragedy, but of endurance, of patience, of quiet beauty. So the next time you look into the night sky, know that many of the points you see are parts of grand galactic clusters, bound together in cosmic cities. But somewhere out there, far from that structure, are the ones we barely see, the galaxies with no home, drifting through the dark, bearing their stars like lanterns, their silence like stories. They are not mistakes. They are not forgotten. They are simply distant. And in that distance they hold a kind of truth we might otherwise miss. They are the stillness between the movements, the hush between the notes, the proof that even the universe in all its expanding fire and force makes room for quiet. And sometimes in that quiet, the most enduring light is found. Far beyond our sun, past the familiar cadence of rocky planets and gas giants, there are worlds so strange, so beautifully unthinkable, they seem like stories whispered from a dream. These are the planets made of diamond and fire, real, confirmed places, orbiting distant stars, each one holding in its orbit a chemistry and structure that stretch the edges of imagination. They are not like Earth. They are not even like Jupiter or Neptune. These are the quiet anomalies of the galaxy, where pressure sculpts carbon into crystal, where heat churns endlessly under skies of metal and glass, where storms rain molten rock and horizons flicker with unimaginable colour. They do not exist to please our sense of comfort. They exist to remind us how much more there is to see. One such planet is 55 Cancri E, orbiting a star just 40 light-years away. It is what astronomers call a super-Earth, larger than our planet but smaller than Neptune. It orbits extremely close to its star, completing one full loop in just 18 hours. So close that its surface is likely scorched, temperatures soaring above 2000 degrees Celsius. At that heat, rocks can melt, atmospheres can vanish. But what makes 55 Cancri truly extraordinary is what it may be made of. Based on its density and orbital behaviour, scientists suspect its interior is rich in carbon, and under the immense pressure deep within, that carbon could crystallise, not into coal, but into diamond. A planet forged in fire, crusted and cool perhaps, but with a heart that sparkles not metaphorically but literally. Imagine standing near such a world. You would not survive the heat. The air would be vaporized minerals. But in your imagination you might see glints beneath the surface, see the hardened folds of pressurized beauty. A place of extremes, heat, gravity, brilliance, yet also a testament to what matter can become when given the right conditions. We think of diamonds as rare, delicate things. On Earth they form deep underground over millions of years under immense pressure. But in space, with enough carbon and the right conditions, a diamond planet might not be rare at all. It might be just one variation in a vast gallery of planetary diversity. And this is only one example. Consider WASP 12b, another planet that orbits perilously close to its star. It is a gas giant like Jupiter, but far hotter, so hot that its atmosphere is being stripped away, drawn toward its star-like steam toward a flame. It is stretched, distorted by tidal forces, its shape more like a football than a sphere. Its skies glow with blazing carbon, and scientists believe it rains molten droplets of titanium and aluminum. This is not weather as we know it. This is chemistry turned theatrical. A place where the boundary between solid and liquid becomes a dance of heat and gravity. On another world, HD 1973b, it rains glass. Shards of silicate whipped by the winds that scream at 5,000 miles per hour. The atmosphere is deep blue, not from oceans but from light scattering in a haze of vaporized minerals. To look at it from afar is to see a tranquil azure orb, but to visit it would be to enter a storm of impossible violence, a place where the very air cuts like knives, and silence is replaced with the roar of supersonic gales. Beauty from a distance, brutality up close. It reminds us that nature does not ask to be understood through comfort, it simply is. And there are planets where fire is not an occasional visitor, but the entire landscape. Lava worlds like K2 141b, which are so close to their stars that their surfaces are oceans of molten rock. On one side, always facing the star, rock vaporizes and rises into the air. Winds carry this rock vapor across the planet to the cooler night side, where it condenses and falls back down as lava rain. The very crust of the planet melts and re-hardens in cycles. The planet has a rock cycle not unlike Earth's, but one that moves not in millions of years, but in hours, like a pulsing geological breath. Such a world pulses with intensity, and its entire environment is shaped by the balance between evaporation and rain, not of water, but of stone. These planets exist. We know them not from direct pictures, but from delicate measurements, wobbles in starlight, dips in brightness, spectra of light filtered through alien atmospheres. We infer their traits from shadows and shifts, and yet, with each detection, we understand a little more, not just about these individual worlds, but about what a planet can be, about how varied, how creative the universe truly is. Sometimes we even find planets that seem like contradictions. Take Gliese 436b, a Neptune-sized world where it snows fire. Its surface is covered in hot ice, a strange form of water compressed into a solid by pressure, yet still burning at hundreds of degrees. Ice and flame together. In our world they cancel each other. In this world they coexist. And that coexistence is not chaos. It is equilibrium, held in place by gravity and heat and time. Nature does not follow our logic. It builds from its own palette, and sometimes what it paints looks nothing like what we know. Then there are the rogue planets, worlds that drift without stars, cast out from their solar systems, moving silently through the cold of space. Some may be small icy wanderers. Others could be massive gas giants still glowing faintly with leftover heat from their formation. Without a sun they do not shine. They are not warmed by light. Yet some may have internal heat, kept alive by radioactive decay or ancient collisions. Some might even have subsurface oceans warmed from within, hiding life in darkness. These planets of silence and shadow defy what we expect. They challenge the notion that a planet must belong to a star to be alive, to be worth knowing, to be real. All of this shows that the category of planet is not a simple box. It is a spectrum, a canvas, a wide open field of possibilities. There are carbon worlds, lava worlds, gas giants with metallic rain, ice planets with fires inside. And perhaps even stranger ones await. Worlds made of helium snow, or with atmospheres rich in chlorine, or crusts studded with rare elements. The more we look, the more we find that planets are not rare at all. They are the rule, not the exception. And yet even within that rule, the diversity is staggering. These planets of diamond and fire, of glass and rock vapour do not exist for us. But in a way they speak to us. They show us that the universe is not a repetition of Earth. It is an orchestra of extremes, and Earth is but one gentle instrument in a symphony that includes the harsh and the radiant alike. These other worlds may never host life, may never be visited, but their existence expands the language of nature. They're the poems the cosmos writes when it is not trying to rhyme. Let us now move gently inward, not through space but through understanding, as we settle deeper into these extraordinary worlds where fire glows beneath every cloud and diamonds may lie in seams beneath the crust. It's easy to think of planets as distant spheres, names in a catalogue, numbers in a list, but each one is a story, a unique response to the ancient ingredients of matter and time. And in those responses, we find nature experimenting not just with geology or chemistry, but with possibility itself. On Earth, life shaped our view of what a planet can be, one that breathes air, cradles oceans, cycles water through clouds and roots. But out there in the wider stretch of sky, there are planets with no such rhythms. They breathe sulfur or iron or none at all. They cycle not water, but magma and vaporized minerals. And they show us that the universe has never been limited by our imagination. One such world is Koirote 7b, a planet so close to its star that it's likely tidally locked, forever showing one face to the burning light and one to the eternal dark. On the day side, temperatures soar to 2000 degrees Celsius, enough to vaporize rock and metals into a thin, glowing atmosphere. The rocks themselves become vapor, rising like steam, forming clouds of silicates that drift on supersonic winds to the cooler night side. There, they condense into mineral rain, perhaps forming pools of molten rock, or solidifying into strange crusts before the cycle begins again. A world where rocks take the place of water, where clouds are made of granite dust, where rain burns before it ever touches the ground. And yet it functions, it holds together, not in chaos, but in balance. An atmosphere sculpted by pressure and temperature alone. Then there's Kepler 10b, another close-orbiting rocky planet, with no atmosphere left to shield it from the star's intensity. Its surface may be a vast lava field slowly hardening over time, only to crack and melt again in perpetual cycles of heat. Here, volcanoes could spew metals. Rivers of molten iron might flow beside plains of cooling basalt. But unlike Earth, where tectonics and weather reshape the land over eons, these surfaces change in a different rhythm. A rhythm not guided by seasons or continents, but by proximity to a star so near it becomes both sky and furnace. These worlds are scorched not into ruin, but into another kind of order, a choreography of elements responding to extremes. In contrast, some distant planets offer colder, stranger variations. Take Ogil 2005 BLG 390 LB, a planet found using gravitational microlensing, a technique that uses the bending of light around massive objects to detect distant bodies. This planet is likely icy, far from its star, if it orbits one at all. Its surface could be frozen solid, with temperatures dropping to 220 degrees Celsius. But below that icy crust, under the pressure of layers and the faint internal heat of its core, there may be a subsurface ocean, dark, sealed, and quiet. A sea not touched by sunlight but warmed by decay and time. On Earth, we've found life in similar places, around deep sea vents, inside Antarctic lakes beneath glaciers. If life could survive there, maybe it could survive here too, in this frozen, drifting world where no star warms the sky. This thought of life in silence opens another door. We've imagined fire worlds and diamond crusts, but what of biospheres? Could a planet of extremes still cradle something living? Perhaps not on its surface, but within. Scientists speculate that some gas giants might harbour habitable moons. These exomoons, orbiting massive planets far from their stars, could be warmed by tidal forces, gravity pulling and flexing them until heat builds inside. Much like Jupiter's moon Europa or Saturn's Enceladus, where icy shells cover oceans deep below, these exomoons might hide entire ecosystems in secret seas. We may never see them directly, but if their planets pass in front of their stars just right, we might catch hints, tiny dips in starlight, traces of gases in atmospheres, quiet clues waiting in the data. Then there are carbon planets, those formed in environments rich not in oxygen, like Earth, but in carbon. Their rocks would be made of carbides, their surfaces perhaps black and tar-like, their mountains shimmering with graphite. In such places, the pressures might naturally create layers of diamond just beneath the crust. If plate tectonics or asteroid impacts expose those layers, entire landscapes could be studded with crystal. Imagine that. Mountain ranges of diamond, lakes of liquid hydrocarbons, skies tinted yellow or dark grey with soot and gas. It sounds like fantasy, but it's physics, unfolded under unfamiliar conditions. Our growing catalogue of exoplanets, now numbering in the thousands, continues to surprise us. We find planets with wildly eccentric orbits, swinging close to their stars and then flung far into cold space, creating seasonal extremes beyond comprehension. Others orbit dead stars, white dwarfs, neutron stars, surviving long after their system should have ended. One such planet, PSR B25712a, orbits a pulsar. Its skies may flicker with deadly radiation, but it exists, it circles steadily, and it tells us that planets are not fragile ornaments, they are survivors. Sculpted by force, yes, but resilient. The variety of these places suggests something almost poetic, that a planet is not defined by habitability, but by character. Some shine bright with reflected light, others cloak themselves in veils of dust and cloud. Some are swollen with gas, nearly stars themselves. Others are stripped cores, metallic, dense, dark. And between all these forms, the boundaries blur. A gas giant with a solid core, a terrestrial planet with a vaporized surface, a Neptune-sized body with a thick, steamy atmosphere and no surface at all. The more we find, the less our labels hold. The cosmos is teaching us to look not for copies of Earth, but for new kinds of beauty. And in the midst of this gallery, Earth itself becomes even more precious. Not because it is typical, but because it is not. Because it sits in the golden balance, not too hot, not too cold, not too large, not too small. It hosts liquid water, plate tectonics, a magnetic field, and life. Life which reshapes its air, its soil, its very history. The planets of Diamond and Fire may dazzle us with their extremes, but Earth, with its scents and birdsong, its mountains and moss, is just as strange. A planet where stone breathes and water walks uphill, where life paints the air blue, where fire and ice, carbon and water dance not just in contrast, but in communion. So as we continue to find more planets through transits, microlensing, direct imaging, and data still waiting to be interpreted, let us remember that each one adds to a vocabulary of wonder, that even if we never visit them, their existence reshapes our understanding. They remind us that nature's imagination exceeds our own, that creation is broader, deeper, and more diverse than anything we have yet dreamed, and that in the quiet turns of distant orbits, the universe speaks in crystal and flame. Let us now bring our journey among these extraordinary planets to a gentle close, not with finality, but with the deep breath of reflection, like the last slow orbit of a satellite before it fades into darkness. Because the story of diamond worlds and fire-rained skies is not just about distance or composition, it's about wonder. It's about how even in the quiet vacuum of space, creation writes poems in carbon and flame. These planets, drenched in pressure, whipped by glass storms, encased in molten seas, are not chaos, but patterns beyond our intuition. They are reminders that the universe does not need our permission to be strange, nor our understanding to be beautiful. They simply are, and in that being, they offer something profound. Consider the music of orbit. Even the most volatile of these planets, those that race around their stars in hours, those blasted by constant radiation, do so with rhythmic precision. They rise and return in perfect intervals, marking time with every pass. Their consistency is not broken by their strangeness. Their revolutions are quiet affirmations that motion, even in a furnace, can be graceful. They are the dancers of extreme heat and pressure, spinning through environments we can barely imagine, yet doing so with elegance. It tells us something subtle, that harmony is not the absence of force, but the ability to persist within it. And while many of these worlds seem hostile to life as we know it, they still expand the possible. We now understand that life might not require sunlight or open air. It might cling to the walls of undersea vents, drift in clouds of gas, or bloom in chemicals foreign to our biology. There are theoretical planets with hydrogen seas, ammonia clouds, or atmospheres rich in methane. Some models suggest life could even exist in supercritical fluids, substances that are neither gas nor liquid, but something in between. We have yet to find such life, but the planets show us where to look. They hint at biochemistries we haven't imagined, metabolisms shaped by alien suns, senses evolved to interpret entirely different spectrums of light. And maybe in this vastness, it is not life that is rare, but familiarity. Maybe Earth is not the standard, but the exception, a singular combination of ingredients that allow not just life, but consciousness to emerge. If so, the planets of Diamond and Fire are not reminders of what is missing, but of what else is possible. They tell us that nature's creativity is not limited to soft soil and blue oceans. It extends to basalt lakes, to raining minerals, to skies scorched in ultraviolet flame. And in that truth, we glimpse a kind of peace, that we are part of something much wider, much older, and much more generous than we knew. Now think again of a carbon planet, its core dense with diamond, its crust a matte layer of graphite and tar. No oceans, no trees, but beneath that crust pressures crackle, heat builds, time presses carbon into crystal. These aren't the cut stones we wear in rings or place on velvet, they are planetary. They are continents of diamond. Their shine is not seen by sunlight, but sensed in their mass, their density, their motion. A kind of quiet wealth, not of value, but of transformation. Something ordinary made extraordinary through time and force. Or imagine a rogue planet, unlit by any star, coasting through the dark. No sunrise, no seasons, yet inside heat. A molten core, perhaps, a frozen surface, and beneath it, water, liquid and ancient. This is not science fiction, it's science unfolding. Even in darkness, energy persists. Even alone, a planet can burn. These are the truths that the universe holds, that even without light, a place can matter. Even without neighbours, a path can continue. These truths apply to planets, and perhaps quietly they apply to us, because when we gaze out into the night, we are looking into a sea of endless possibility. Each point of light may hold a dozen or 100 worlds, each with its own weather, its own minerals, its own relationship to time. Some bake in eternal heat, others sleep in cold silence. Some are wrapped in gas and bear surfaces harder than steel. And each, whether visible or hidden, real or only theorized, shapes our understanding of what a planet can be, not just in structure, but in spirit. The study of these strange worlds does not end with observation. It continues in laboratories, in models, in mines. Scientists create high-pressure environments to study what silicates do at thousands of degrees. They simulate atmospheres that rain metal. They map the ways light interacts with clouds of iron and sodium. And all of this reveals more than just data. It reveals that even the extremes can be understood, that even chaos has laws, that even the wildest places in the cosmos can be brought gently into clarity. And so we learn, slowly, carefully, not with conquest but with curiosity, not to master these worlds but to witness them. We ask not how to change them but how to know them, how to let the conditions speak. And in doing so, we expand our own capacity for understanding, not just of planets, but of nature, of creativity, of resilience. Because in the end, the planets made of diamond and fire, of vapor and wind, are not just distant phenomena. They are part of our shared cosmos. The same atoms that form their clouds form our bones. The same gravity that shapes their paths holds us to the Earth. We are not separate from them. We are born of the same origins, stardust cooled into structure, flame calmed into form. The universe does not send us messages, but it does offer us patterns, and in these planets it offers us a truth as beautiful as any sunrise. That matter, when given time, becomes story. So let us carry their stories with us. Let us speak of worlds where lava reigns, where diamonds lie beneath our feet, where light cannot reach but heat still flows. Let us speak not just in terms of temperature or mass, but in terms of awe. Let us be the kind of beings who, upon finding a planet covered in crystal or fire, do not turn away in fear, but lean closer in wonder. For the universe is not quiet. It sings in every orbit, in every storm, in every unseen moon. And the planets we now find are not outliers. They are verses in the poem of existence, strange, distant, real, and always, always waiting to be heard. There is a kind of light in the universe that doesn't arrive on time. It travels faithfully, uninterrupted, for billions of years, carrying with it the echo of distant stars and forgotten galaxies. And yet when it reaches us, it arrives from a time that no longer exists. This light, ancient and slow, is not the kind that warms your skin or casts a shadow. It is stretched and softened by the expansion of space, turned from visible glow into radio waves and microwaves, into whispers so quiet that only the most sensitive instruments can hear them. And still, it arrives, late, but not lost. It is the light that tells us what once was, the light that paints a picture of the early universe on the black canvas of today, the light that arrived too late to change the past, but just in time to help us understand it. When we look at the sky, we are not seeing stars as they are. We are seeing them as they were. Even the light from our own sun is 8 minutes old by the time it touches the Earth. The light from Alpha Centauri, the nearest star system, is more than 4 years old. But when we peer deeper into the thousands of galaxies captured by the Hubble Deep Field, for example, we are looking at light that left its sources over 10 billion years ago. We are seeing the cosmos not just across distance, but across time. In astronomy, distance is measured in years of travel. A galaxy 10 billion light years away is not just far, it is 10 billion years ago. A cosmic memory preserved in light. And yet some of the oldest light we see is not from stars at all. It is from the fireball that came before them. The cosmic microwave background, or CMB, is the oldest light in the universe. It was released just 30,000 years after the Big Bang, long before galaxies formed, before stars ignited, before planets had names. Before that moment, the universe was a hot, dense soup of particles. Photons couldn't travel freely because they constantly scattered off electrons. But as the universe expanded and cooled, electrons joined with protons to form neutral atoms, and suddenly light was free. That first light has been travelling ever since, stretching as space itself has stretched, softening from searing heat into a gentle microwave glow. It now fills the universe like a mist, uniform, persistent, and quietly informative. Imagine standing in the middle of a quiet field at night, arms open to the sky. All around you, this ancient light is washing over the earth. You cannot see it with your eyes, but it's there, not just coming from one direction, but from every direction equally. It is not the light of a single star or a distant planet. It is the leftover breath of the beginning, a soft radiation that tells us there was a time before stars, before darkness even, a time when the whole universe glowed. The CMB is faint, but it is not featureless. Embedded in its subtle variations are clues to everything that would come later. Tiny fluctuations in temperature, differences of just millionths of a degree, reveal where matter began to clump, where gravity gathered the seeds that would become galaxies. It is like a baby picture of the cosmos, where every slight shadow foretells the structure of the future. And though it took nearly 14 billion years for that light to reach us, it has helped us map the entire shape of the universe, its age, its curvature, its contents. This light may have arrived late, but it carries everything. And it's not the only light that does. Light from supernovae, massive stellar explosions, reaches us after crossing the vacuum for millions of years. When we catch a glimpse of one, it is already over. The star has already vanished, its dust scattered, its planets gone, and yet the light remains, telling us not what is, but what was. In some cases, gravitational lensing, when light bends around massive objects like galaxies or black holes, can even create echoes of that light, allowing us to see the same event multiple times from slightly different paths. The cosmos, it seems, is full of second chances. Even more haunting are the quasars, distant, hyper-bright beacons powered by supermassive black holes at the centres of early galaxies. Some of the light we receive from them began its journey more than 12 billion years ago. These objects are so far away that the universe itself has stretched their light into longer wavelengths, red-shifted it, until it becomes a faint signal nearly lost to time. Yet we detect it, we measure it, and through it, we glimpse not only the black holes that powered them, but the state of the universe itself in its youth, when stars were new and galaxies were still taking shape. There's even stranger light, ghost light, some call it, light that was never intended for us. Some galaxies are surrounded by diffuse halos of light made from stars stripped during collisions, or from gases ionized by forgotten bursts of radiation. This light drifts, soft and structureless between galaxies. It doesn't belong to any one object. It doesn't have a clear source, but it glows, faintly, persistently, as if the past refuses to be fully erased. And sometimes light takes a longer route. It may bounce off dust clouds, scatter in interstellar gas, or bend its path around galaxy clusters. In doing so, it's delayed, not by seconds, but by millions of years. When we finally detect it, we are seeing a detour, a path unplanned. This scattered light can teach us about the shape of space itself. It maps the invisible. It exposes the contours of things we cannot see directly. Like moonlight reflected on water, it is not the source that matters, but the echo. And so, throughout the universe, light arrives too late to save what created it. But it arrives in time to teach us. We are forever watching ghosts, the light of stars already dead, the image of galaxies long faded, the energy of moments that no longer burn. But these ghosts are not mournful, they are luminous, they are kind. They remind us that in this universe to be seen is to be remembered, and that memory, even when delayed, still matters. If you listen closely, not with ears but with the quiet of wonder, you can almost hear it. Not the light itself, but what it carries. The pulse of a supernova, the shimmer of a forming galaxy, the soft hum of a cooling universe. Each photon is a letter in a story that took billions of years to arrive, and now, finally, it touches us. Not to warn, not to burn, just to say, I was here, I mattered, and now you know. Let us drift now even farther back, past the veil of what we can easily see, into the soft hum of a universe still forming itself, a place where time was young and space had only just begun to stretch its arms. In the darkness before stars, before planets, before structure, there was light. But it was not the sharp, clean light of suns. It was a glowing fog, a sea of photons trapped in a crowded dance with particles. Every direction was the same, every moment filled with collisions. The early universe was not quiet. It was dense, hot, and humming with motion. But as it cooled, that dance slowed. At last, light slipped free. That light, the cosmic microwave background, has never stopped travelling. Imagine that freedom. A photon, released from its birthplace in a universe only a few 100,000 years old, now stretched across billions of years, never stopped by anything, never altered but for the slow tug of cosmic expansion. That photon might have passed between colliding galaxies, through the heart of empty voids, across vast webs of dark matter. It might have been bent just slightly by gravity, or slowed by its passage through clouds of hydrogen, but it continued, and now it brushes gently against the dish of a radio telescope on Earth, adding its whisper to a map that lets us see what we cannot touch, the shape of the beginning. And the map is detailed. It is not a smear. It is not static. It is textured like silk beneath a microscope, showing tiny ripples, fluctuations in temperature so small they seem like imperfections, but they are the blueprint of everything. Those tiny shifts are the fingerprints of quantum jitters amplified by inflation. Brief, early moments when the universe expanded faster than light could travel. From these jittery seeds came the galaxies, stars, planets, even us. The CMB shows us not just where we came from, but how small differences became vast structures. And all of it arrives late. All of it is ancient, yet all of it is true. As we read this light, we find time written in colour. Redshift tells us how long a photon has travelled. More redshift means more distance and more delay. Looking deeper means looking further back, and so light becomes a time machine. A telescope becomes a form of archaeology, and what we see with it are the echoes of transformations. We see galaxies as they were just forming, chaotic clouds of stars without arms or symmetry. We see the first quasars, black holes gorging themselves on primordial matter, lighting up like cosmic lighthouses in a universe still trying to understand gravity. We see stellar nurseries that are now quiet. We see chaos that turned into order, order that turned into form. Sometimes we even see things we did not expect, galaxies that seem too old for their distance, stars that formed too early, light that contradicts our models. These surprises don't break science, they strengthen it. Because light cannot lie, it can only travel. And so when something strange appears, it means the story is richer than we thought. Perhaps stars formed sooner than we assumed. Perhaps matter clumped faster. Perhaps there were unseen forces, dark energies shaping the pace of creation. Each discrepancy is a new question, a new layer of wonder added to the story. And the story does not stop with photons. Neutrinos, near massless particles created in the early moments, also travel, largely untouched, across the cosmos. They too arrive late. They too carry messages, but they are harder to catch, harder to measure. The neutrino background is not something we've fully mapped yet, but it exists, another layer of quiet memory, a deeper shadow of the Big Bang. There is also gravitational radiation, the oldest kind of wave. Gravitational waves stretch and compress space itself, and somewhere in the universe there may still be whispers of the earliest ones, waves from the very moment of inflation, etched into the fabric of space. If we find them, they will be the faintest of rhythms, the most delicate of signatures, but they will tell us not about stars or galaxies or even atoms, but about time itself beginning. And what of the light that never arrives? There is much of that too, light from stars that shone and faded while Earth was still molten, light swallowed by dust, absorbed by gas, lost to the crowding of the cosmos. For every photon we catch, there are many we miss. But even absence speaks. The shape of a shadow can reveal what blocked the light. The curve of a spectrum can show what absorbed it. In this way, darkness becomes a teacher. Gaps in starlight tell us what floats between galaxies. Missing colours tell us what gases drift in intergalactic space. This is science that listens even to silence. Instruments like the James Webb Space Telescope have begun to open even more of this delayed light to our view. Its infrared eyes can see the stretched light of galaxies formed mere hundreds of millions of years after the Big Bang, galaxies so far away that their light has spent nearly all of time reaching us. And yet it arrives, and paints pictures so sharp we can count stars, measure dust, guess at the first ingredients of worlds like ours. And we know without doubt that every photon we catch from those galaxies is older than any tree, any mountain, any ocean on Earth. They arrived too late to change what they left behind, but they arrived in time for us to see, to wonder, to learn. It's not just distance that makes light arrive late. Gravity too slows it down. Light passing near a massive object like a galaxy cluster is delayed, not lost, but bent, stretched, curved into arcs and halos. We see these distortions, gravitational lenses, as rings of light around dark centers. And sometimes we see the same supernova appear twice or more, because its light took multiple paths around a lens. Time folds in these moments. The same event played again, not because it repeated, but because the universe curved time itself. In this way, gravity becomes a mirror, and the past, for a brief moment, becomes visible again. Even the stars around us, stars we think we know, are memories. Their light has travelled years or centuries. We see them as they were. If one were to vanish now, we would not know for a long while. In that delay, there is poetry. A star may be gone, but its light remains, still crossing the vacuum, still reaching us, still saying, "I was." And that message can be comforting, because in a universe ruled by time and decay, light keeps its promises. It remembers, it arrives, even if late. So we look, not to change the past, but to understand it. We read the sky like a library, where every photon is a page, every wavelength a word. And though the books may be ancient, their messages still shine. The light that arrives too late does not apologize, it simply glows. And in its glow we find our place, not at the centre, but as readers, as witnesses, as those lucky enough to receive the stories of the stars. Now let us arrive, softly and unhurried, at the closing curve of this cosmic tale, not with conclusion, but with calm continuation, as though following the final threads of starlight until they vanish into the fabric of our thoughts. The light that arrived too late continues to pour in, every night, every day, quietly, across all skies, whether we notice it or not. It does not fade. It does not hurry. It simply continues, like a breath held for eons and finally released into waiting hands. And in its arrival we are reminded that light is not only about seeing but about remembering. It carries with it the imprint of what was, not to recreate it, but to let us bear witness, to let us listen as the universe tells its story long after the characters have left the stage. Every photon that reaches us, especially from the deep cosmos, has crossed a path so vast and uninterrupted that it seems almost improbable. Through trillions of miles of empty space where it could have struck dust, deflected, scattered, or been absorbed, it instead survived. A survivor of silence. And when it enters our instruments, a telescope mirror, a radio dish, the sensor of a satellite, it completes its journey. It becomes data, a number, a pixel. But before it was that, it was an echo, a traveller, a messenger. The light that arrives late is not broken, it is simply old. And in that age lies beauty. Some of the most exquisite findings in modern astronomy are not from what we see now, but from what we see then, from light so delayed it predates our planet, our solar system, even our galaxy's spiral arms. These photons have been travelling since long before Earth cooled, before life stirred in oceans, before eyes evolved to see. They were already on their way when the first trees breathed air, when the first birds folded wings against the wind, when the first humans lit fire in caves. And now they reach us, not as explosions or grand gestures, but as subtle flickers in the dark, small signatures in telescope readouts, quiet confirmations that something long gone still left something behind. There is comfort in this. A galaxy may die, but its light will continue for eons, crossing the void. A star may collapse, but its brightness will keep travelling, revealing its story to observers who are themselves part of newer stories. The universe forgets in motion, but it remembers in light. And perhaps so do we. We use these late arrivals not only to study, but to connect ourselves to moments we could never have witnessed, to events that occurred before any eye could see them, and in doing so we stretch the borders of memory across the cosmos. One of the most poetic tools in astronomy is the light curve, a graph showing how a star's brightness changes over time. From these curves we can tell if a planet is crossing its face, or if a supernova has erupted. But what we are really watching is time itself, the rising and falling heartbeat of something far away, long ago. Light curves are records of breath. They show that even in death stars pulse. Even in disappearance they leave rhythm. We study these curves, these oscillations, these flares and fades, and through them we listen to stories written in brightness. And some of these stories are still being revealed, like light delayed by galaxies we cannot yet name. Some light curves are distorted, stretched by gravitational lenses that haven't yet been fully mapped. We see arcs, repeated images, magnified flickers, and with them opportunities to measure space with precision unimaginable before. The delay of light, once seen as a limitation, becomes a gift. We can track it, time its arrival, compare multiple paths, and from that we not only learn where the light came from, but what lay between. In this way, the space between things becomes visible. The invisible becomes traced by the very delays that once seemed like obstacles. Even our own galaxy participates in this slow dance. At its centre lies Sagittarius A, a supermassive black hole whose influence bends time and light. When a star passes close, its orbit stretches like rubber, and its light is warped. We watch patiently for flares, for shifts, for signs that something has passed too close. And when that light arrives, often years after the event, we learn a little more about gravity, about mass, about the structure of what cannot be seen. All of this suggests that the universe is not just expanding in space, it is expanding in story. And light, especially the late arriving kind, is the ink. It writes in sins, it sketches in delay, it reveals in reflection. It does not demand urgency, it does not insist on immediacy. It simply moves forward, bearing its history without rush. In this way, the cosmos teaches us patience, teaches us to look, not just for what is new, but for what is old and still shining. The light that arrived too late will always arrive. Long after a galaxy fades, its glow will continue. Long after a civilization vanishes, its radio waves will still ripple outward. We send out light of our own, intentionally or not. Every broadcast, every signal, every reflection of sunlight off our atmosphere is a message in motion. One day, perhaps, some distant observer in another system will see Earth as it was 1,000 years ago. Perhaps they will catch the glint of our satellites. Perhaps they will study our atmosphere and wonder what kind of life once breathed here. And maybe, in that moment, they too will be reading late arriving light. They too will marvel not just at what they see, but when they see it. Because time and space are not separate. They are partners, and light is the thread between them. A thread so fine yet strong enough to carry the weight of all that has ever burned. So when you next gaze into the night sky, let your eyes soften, let your thoughts slow. Know that the light touching your skin, the starlight brushing your retinas, has been travelling longer than most things ever live. Know that you are not seeing the stars as they are, but as they were, and in that gentle delay, find something beautiful, something forgiving, something infinite. Because in the end, the light that arrives too late is not behind. It is just on time for those ready to listen. And if we listen closely enough, we may realize it's not only the universe telling us its story, it's also inviting us to be part of it, to join the glow, to echo forward, to become one more flicker sent softly into the dark.